everyone, we are discussing maximum ice cream bar question today, and the question says that we have to use counting sort. So let's start with what is counting sort, and forget the word counting for now. There is this sort word, which means that if, like, let's say we are given an array. Now by sorting we mean that we have to sort this array, right? So when you do sorting using merge sort or let's say quick sort, our time complexity is big O of n log n. Now when we say counting sort, our time complexity is big O of n. And now we'll see how do we perform counting sort. So in counting sort we have two things. The first one is the range of numbers, and in this array what is the minimum element? It is 1. So 1 is my minimum number, and what is the maximum number? 4. So 4 is my max number. So inclusive 1 and 4, we have 1 and 4 as the range. So starting 1 up until 4, we will store all the natural numbers, and we'll store their frequency. You can choose any data structure based on the programming language you're choosing. So let's see how we will calculate the frequency. So we'll iterate through the elements, and whenever we encounter any particular number, for that particular number we'll increase the frequency. So when we iterate through this array, this is how our number and frequency looks like. So now we are going to code in Java. So that's why we have this number and frequency list. Now in Java, a very optimal way to store this is using arrays. Let's say I want numbers 1 2 3 4, and if I let's say have a array of like length 5, so 1 2 3 4 numbers are there, and 0 is also there, so element 0 ka frequency 0 by default, and for every number we have its frequency at that array index. So yeah, this is how we listed this. And from this array, can we get the sorted array? Let's see how we'll get to that. So basically right now I am at 0th index, right? So my 0th number, like my number 0 appears 0 times. So we are going to skip 0, and now we'll go to 1. Now 1 appears 2 times, so we'll write 1, and we'll again write 1, and we'll write this 2 times. We've written this 2 times, and now we move ahead. So now we come to 2. Now our number 2 appears once, so we are going to write 2 once, and then we move forward. Then we have 3, and then 3 appears once, so that's why we'll write 3 just once. And now when we move ahead, we encounter 4, and that's when we write 4 for like 1 time. So is this the sorted array? 1 1 2 3 4? Yes, it is. Okay, now let's understand the question. So we have n number of ice creams, and every ice cream has a price. So this is the price which is listed here. We have some coins. Here we have this 1 2 3 4 5 coins, and we want to maximize the number of ice creams that we can buy using these using these coins. So to maximize how many number of ice creams that I can buy, let's sort these ice creams based on the price. So we've sorted this. So now we'll keep on taking ice creams up until we have coins remaining. So we'll start with this index, and right now we'll check if we can take the purple ice cream. We want 1 coin. Do we have a coin? Yes, we have. So we're going to buy. So when we buy, we have this brought. We buy this, and then we move our pointer. Now we want to see if we can buy the green ice cream, maybe green apple ice cream, something. So now we see its price is 1. Do we have a coin? Yes, we do have 1 coin. So we can buy. So we'll buy. Now we have brought 2 ice creams, and now what we are going to do is see if we can buy this ice cream. So yes, we need 2 coins for that, and we do have 1 and 2 coin. So we're going to buy this. So now we have 3 ice creams that we have brought, and now we'll check if we can buy this, purple ice cream something. So now we want 3 coins, but we only have 1 coin. We are short of 2 coins. So this means we don't have enough money, and we can't buy this. And starting this, we know that elements beyond this will be greater than or equal to 3. So that's why we can buy no more ice creams. So how many ice creams could we buy at max? It was 3. So if we had to maximize the numbers that we brought, number of ice creams that we brought, it is 3 in this case. Okay, moving on. We'll come to the code part. So in here, we have this, we have a maximum, we are basically, you remember we need a range for counting sort, which is like, we need a lower bound and we need the upper bound. You remember for that? From that, now we have to need to have 2 elements. Now let's say, वैसे तो in the question it says that we can't have any ice cream with price 0, but let's say we say 0. So this is a lower bound. Now we want to see what is the upper bound. What's the upper bound? So right now we have coins and we have cost. So let's say my maximum cost of an ice cream is, let's say, 100. And the maximum coins I have is 25, let's say. So do I really need to store 100 or do I really need to store 25? Actually, I need to store whatever is minimum of these two. So that would be the range. So that's the thing we have done here. We have used an optimization. So now what we are going to do is, we are going to iterate through the array and we are going to find a maximum cost. So and then what we are going to do is, whatever is the minimum of coin and maximum cost, we are going to store that here. So this is what we find out, a maximum range. Okay. Now at line number 11, what we do is we initialize an array so that we can store the frequency. And what will be the maximum index of the array that we initialize? So my maximum index will be size plus 1. Why? Suppose our maximum value is n, the range is n. So I want to store the frequency of nth element. So that's why we have this size of array as n plus 1, so that we could have the last index as n. Now from line 13 till 18, what we are doing is that we are actually storing the frequencies. Now notice this line which says if cost is greater than size. What it means that, let's say we have n elements and some cost of some ice cream is maybe 2 n plus something, n plus maybe 5. So can we really buy that? No. If I don't have those many coins, I can't really buy. So if cost is greater than the size of the range, so in that case what we do is we skip that element. So that is what we've done in line number 14 and 15. Okay, now we store all the frequencies. So this is up until here. I think it should be clear. Now we initialize count as 0. So my count is 0. We've initialized this. So we're basically counting the ice creams that we can buy. Now, then we return the count at the end. Now what we are doing from line 22 till line 32, what we are doing is we are iterating starting index 1. Why? Because the question says that we can't have a price equal to 0. So that's why we're starting from 1, which is the lower range. And we'll go up till the size of the the last element. So which is I is less than or equal to size, since number of elements is size plus 1. So that's why less than or equal to. Now what we do is, if we don't have enough coins to buy, then we break from the loop and we return the count. Else, let's say if we do have coins remaining, in that case what we do is, like, we'll first check if ARR of I is 0. What do we mean by that? That particular ice cream is actually present in the array. That particular ice cream, let's say, is there, like the frequency is not 0. If the frequency is 0, it means that we do not have any such thing in our original arrays. So that's why we are doing this check. By the way, this is not required, but I added this. The reason is that when I added this, my code optimization went from 93 to 99%. Anyways, my runtime actually was improved. Now what I do is, I will buy, then I can see how many elements can I buy. Now let's say I have, let's say, 10 rupees, and the price of an ice cream is, let's say, 5 rupees. So how many ice creams can I buy? I can buy 2 ice creams, right? So that is what we've done here, coins by I. And then we'll check like the minimum ARR of I, which is like the how many ice creams are there. Are there enough ice creams? So whatever is the minimum of these, we'll take it, we'll add it to the count, and then we will decrement the number of ice creams into the price. So I is the price, right? And then we'll return the count. So yeah, this was it from my end. I hope I was able to explain this really well. Thank you.